Well, we have finally made it to reaction prediction number 30, our final reaction prediction of the year. It is my hope that after now 30 of these reactions, you are able to more effectively predict the products of reactions, and that maybe by the time that you move on from here, this will be a skill that will serve you well. So let's start with the first one. Solutions of, so obviously aqueous manganese sulfate and ammonium sulfide. So MnSO4, aqueous, ammonium, NH4 again, aqueous. And this is a double replacement reaction that should form a singular precipitate as our product, with our two spectator ions taking place, or being also in the products and reactants. This should have been a nice, easy one for us. Excess concentrated, that if you remember is our clue that this reaction is a complex ion reaction. So we start with ammonia that reacts with suspension. This goes back to our solutions chapter. Suspension just means precipitate, so the solid, of silver chloride. This reaction occurs because the ammonia complexes with the silver. If you remember with the numbers there, that will complex so that we get that dicyanoargentate ion and then a chloride ion. So we should end up with two ions in solution. The idea of this is that I'm dissolving the silver chloride. If I can then remove the chloride, I could acidify this. The acidification would also then remove the ammonia, and I would get the silver by itself. Nice and easy reaction there. Okay, the next one, and again, you'd have to balance that. Oh, it asks for the molecular geometry. That's based on what's called the coordination number, or the subscript that goes along with our ligand. You can look in our reaction booklet. There are several of these geometries based on that coordination number. We move down here to number 3, sodium phosphate, again, solutions of. So sodium phosphate, Na3PO4, and zinc nitrate. Again, these are both solutions, and so since they are, we should end up with, I believe it looks like 2 spectator ions and a singular precipitate. And be sure to identify that precipitate. You'll balance this and identify that precipitate in our second part of the question. Solid potassium oxide is added to water. This is a synthesis reaction. You should get one singular product. Now you do have to keep in mind, though, that there is water. So if that product is water soluble, you do need to break it apart into ions and then balance it. Is it acidic, basic, or neutral? And explain. Do not forget to explain. We're in acids and bases. It should make that a lot easier. Solid calcium oxide, CaO, is in the presence of sulfur trioxide, SO3. This is now a singular product, a combination, so synthesis reaction. And so just think of what happens when I combine a calcium and then the oxygen with those SO3s, and I should get one singular compound. And then what is the name of that singular compound? Solutions of, again, solution, and barium hydroxide. So this would be copper 2 sulfate and barium hydroxide, strong base. Again, these are both solutions, and when you put those solutions together, you should end up with some precipitation at the end. And be sure to identify if there is one. If there are 2 of them, then both precipitates. But do break down those reactants, which are both soluble, and balance the reaction. Letter G here, a solution of ammonia is added to ferric chloride solution. This is always a tricky one because a solution of ammonia actually reacts like this. Oops, I got that wrong. Sorry about that. It's ammonia in water, so you get... It actually reacts as ammonium hydroxide, and that reacts with ferric chloride, which is obviously aqueous. So I would do this, when I go through it, I react it like a double replacement reaction. That's the way that I do it. But then when I go down and I treat the balancing, I have to balance it considering that this is really ammonia and water. That will give you your ammonia as a reactant, but it will also give you your proper products when you consider it as ammonium hydroxide. Remember, the ammonium hydroxide is not the reactant. It's just that when it's in water, it will react as ammonium hydroxide. So this works as a double replacement reaction. Use the ammonium and your iron as your cation exchanges. But then when you're going through and balancing it, and I believe you'll see that you have, just make sure you're ever, I believe that you'll see that you'll have, So you should have the water that will end up, there you go. So instead of ammonium hydroxide, we'll have reactants of ammonia and water. And what I would go through is if I balance it, let's say I needed a 2 here. Well, when I rewrote the reactants, that would be distributed here and here. And so I would just replace my whatever ammonium hydroxide is with NH3 and H2O. Those are my reactants, but it reacts like ammonium hydroxide, if I hopefully identified or explained that well enough to you. So again, as we go through this, the solution of ammonia reacts like ammonium hydroxide, but when you write it, you have to write it as ammonium and water as your 2 reactants. Should see at least a spectator reaction, a spectator ion in this reaction. Copper metals, that's Cu, is added to concentrated sulfuric acid. This is a redox reaction. So H2SO4, H plus, HSO4 minus, and now you're going to see your products. Copper being oxidized and sulfur being reduced. You have to look up your oxidizing and reducing agents to remember what does concentrated sulfuric acid break down to, balance it, and then identify your oxidizing and reducing agents. Okay. If you have any questions this week, definitely ask. This is due by Friday. Reaction prediction number 30. We made it to the end.